Hello everyone. So today we are starting ionic equilibrium exercise questions. So first question is, this is question number 44. The ionization constant of phenol is given to you. That is 1.0 into 10 raised to power minus 10. Okay, it is given to you. Now, what is the concentration of phenate ion, or sometimes we can call it as phenoxide ion, in 0.05 molar 0.05 molar solution of phenol? Okay, and pH of the solution, and what will be the degree of ionization if the solution is 0.01 molar in sodium phenate, or we can say sodium phenoxide. Okay, this is the question. Now, first of all, see, ionization constant is given to you of phenol, that is 1.0 into 10 raised to power minus 10. What is phenol first? Phenol is actually benzene and there is OH group on it. Okay, this is called phenol. Okay, now phenol, when it is dissolved in water, you know, phenol is an acid. Okay, so it gives phenoxide ion and H3O plus ion. Okay, now initial concentration, let us take initial concentration of phenol, it is C. Okay, if this concentration is C, here it is given actually, so initial concentration is 0.05 molar, because what is the concentration of phenate ion in 0.05 molar solution of phenol? That means initial concentration of phenol is given to us, it is 0.05 molar. Okay, and it is initially it is 0. Now at equilibrium, out of 0.05, if alpha is degree of dissociation, then it is 0.05 into 1 minus alpha. You know, if it is C, we write it as C minus C alpha, that is C 1 minus alpha. If alpha is degree of dissociation, we write it like this. Good evening Tanya ji. Okay, Anika, Ralam, Abhay, Mansi. Okay, so equilibrium, say alpha is degree of dissociation. Keep in mind, what is alpha here? Alpha is degree of dissociation. Okay, if alpha is degree of dissociation, we write it as 0.05 into 1 minus alpha. So it becomes 0.05 alpha, 0.05 alpha. Because out of 0.05, 0.05 into alpha is ionized. Because say its ionization constant is very less, 10 raised to power minus 10. Very less. So now dissociation constant of acid, that is Ka, is equal to concentration of, we can write it as PHO negative. Okay, and write it as PHOH, phenol as PHOH and phenoxide as PHO negative. Okay, so PHO negative concentration, H3O plus ion concentration divided by PHOH concentration. Okay, so it is 0.05 alpha into 0.05 0.05 alpha, okay, divided by 0.05 into 1 minus alpha, right? And it is equal to, yes, 0.05 cancel, so it becomes 0.05 alpha square over 1 minus alpha, and that is equal to 1.0 into 10 raised power minus 10. So as Ka is very less, so alpha is very less than 1. So 1 minus alpha is very close to 1. 1 minus alpha is very close to 1. So that means it becomes 0.05 alpha square equal to 1 minus alpha is taken as 1. So it is 10 raised power minus 10. So alpha square is equal to 10 raised power minus 10 over 0.05. So it becomes, yes, 100 into 10 raised to power minus 10 over 5, that is 20 into 10 raised to power minus 10. Is it right? So it becomes, yes, alpha is equal to square root of 20 into 10 raised to power minus 10. So it becomes square root of 20 into 10 raised to power minus 5. And what is square root of 20? 4 4s are 16 and 5 5s are 25. So it is almost in between. So it is 4.5 around. 10 raised to power minus 5. See, 4 4s are 16 and 5 5s are 25 and value is 20. That is near to 16. That means it is slightly less than 5. It is slightly less than 4.5. So it is almost 4.47 or 4.48. So this is degree of dissociation. Degree of dissociation of phenol. Okay. When concentration of solution is 0.05 molar. Okay. So what is the concentration of phenoxide ion? It is 0.05 into alpha. That is 0.05 into 4.47 into 10 raised to power minus 5. So it is 2.23 into 10 raised to power these, okay, 10 raised to power minus 6 molar. And pH of the solution, see, the concentration of phenoxide ion is same as that of H3O plus ion concentration. And what is pH? pH is equal to minus log of H3O plus, that is minus log of 2.23 into 10 raised to power minus 6. Okay. So it becomes minus log of 2.23 and take common है ना, and plus log of 10 raised to power minus 6. So it becomes minus log of 2.23 minus 6. So minus log of 2.23 plus 6. What is log of 2.23? So it is 6 minus log of 2.23. So count the number of digits before decimal place, that is 1. So 0 point and subtract 1 from it. Okay. Then we look at the log table of 22 3. So it is 3 4 8 3. So I'm subtracting, take it as 0.35. So it is 5.65. So that is pH. Okay. So this is the case 1. Okay, beta. Now in the case 1, pH of the solution is 5.65 and degree of dissociation is 4.47 into 10 raised per minus 6, sorry, 10 per minus 5, and concentration of H3O plus and phenoxide ion, it is 2.26 into 2.23 into 10 raised per minus 6. Okay. Yes. Now next question case 2. Case 2 of the same question. Now in the question, first we calculate, question was what is the concentration of phenate ion in 0.05 molar solution of phenol and pH of the solution, that we have calculated. Now next question is what will be the degree of ionization if the solution is also 0.01 molar in sodium phenate. See, we have phenol. So phenol gives phenate ion along with H plus ion. Then we have sodium phenate. So it is a strong electrolyte. So we get phenoxide ion, phenate ion and Na plus ions. Okay. Because sodium phenoxide, that is completely ionized. It is 0.01, right? If it is 0.01, so it becomes 0.01 and it is also 0.01. Okay. Now come to this part, PHOH, phenate ion or phenoxide ion and H plus ion, right? So now if concentration of phenate ion, see in this case it is 0.05 molar initially. Now case is different because in addition to phenol, there is sodium phenate as well. Okay. So 0.05 molar phenol is there and at the same time 0.01 molar phenate ion is also there. In the earlier case, we have phenol 0.05 but phenate ion is only 0 initially. H plus ion again 0. Yes, initially it is 0. Okay. Now let's focus on next part, that is at equilibrium. Now at equilibrium, it is 0.05 minus X. Let us say X mole of phenol is ionized. Okay. So it becomes 0.01 plus X and it becomes X. And say in this case there is a common ion effect. So because of this common ion effect, equilibrium shifts backward. because of common ion effect, because phenate is common, okay, one of the product. So equilibrium shifts backward, that means dissociation constant decreases, because dissociation of phenol is further suppressed due to the presence of phenate ion, okay. That's why equilibrium shifts backward, okay. Now see Ka, Ka remains same. So now Ka is equal to, again, phenoxide ion concentration, H plus ion concentration divided by phenol concentration, okay. That implies it is 1 into 10 raised per minus 10, that is equal to 0.01 molar into H plus ion, means X, say 0.01 plus X, so it is almost equal to 0.01 because X is very, very small. It is almost equal to 0.05. It is also equal to 0.01. Okay, so 0.01 into X divided by 0.05 molar. So X, this Ka is same, that is 1.0 into 10 raised per minus 10. So from whole of this, what is X? X is equal to, say, 0.01, 0.05. So it becomes 5 only. So 5.0 into 10 raised per minus 10. This is the X. Okay. 5.0 into 10 raised to power minus 10. This is the value of X. So what is actually X? If alpha is degree of dissociation, so see, you can write in terms of degree of dissociation. So X is actually 0.05 alpha. What is initial concentration of phenol? 0.05. Okay, out of 0.05, this much amount is dissociated. So degree of dissociation, alpha, is equal to number of phenol molecules undergoing dissociation divided by total number of phenol molecules. Divided by total number of phenol molecules. Number of phenol molecules undergoing dissociation divided by total number of phenol molecules. Okay. So number of molecules undergoing dissociation, that is 5.0 into 10 raised per minus 10 divided by total 0.05. So 0.05 means 5.0 into 10 raised per minus 2. Cancel. That is 10 raised to power minus 8. So alpha is 10 raised to power minus 8. Okay. That's it. Do you want me to repeat this question? Or you understood? Tell me, did you understand this question? Yes, beta. Any doubt in it? Say here you can go like 0.05. See, phenol to give phenoxide ion or phenate ion H plus, it is 0.05, 0.01, it is 0.05, minus, sorry, 0.05 1 minus alpha, so it is 0.01 plus 0.05 alpha and 0.05 alpha. You can go like this also. Okay, so x is actually 0.05. This can be neglected. This part and this part 0. Because it is 0.05 minus 0.05 alpha. So this part can be neglected because it is added in 0. Subtracted in 0.05 and it is added in 0.01. See, quick review. Difference is only here. In this case, in first case, see, in first case, we have initial concentration of phenol as 0.05 and initial concentration of phenate is 0. But in second case, it is 0.01, sorry, 0.05 only, but in addition to that, phenate is 0.01. That is the main difference. Rest is same. See, this part remains same. Only this part in the second case becomes 0.01 plus. Here it is 0.05 minus 0.05 alpha. That is same. Here instead of 0, it becomes 0.01 molar in second case. This extra part, because of the presence of sodium phenate in second case, what will be the degree of ionization? If the solution is also 0.01 molar in sodium phenate. That is the major difference. Okay, rest is same. Okay, Ralam, got it? Only difference lies in that part. Okay, and because of the presence of common ion, dissociation further suppressed. Okay, to maintain the value of Ka as 10 raised power minus 10. And because of the presence of 0.01, this X part is neglected. X part is neglected. Okay, so question number 45 now. So question number 45. This is very lengthy question. See, first dissociation constant of H2S is 9.1 into 10 raised to power minus 8. Okay. So calculate the concentration of HS negative ions in 0.1 molar solution. And how much will this concentration be affected if the solution is 0.1 molar in HCl also. So first, let us focus on the first part. So case 1. Just to calculate of HS negative ion concentration in 0.1 molar solution. Means 0.1 molar H2S solution. So see, H2S, you know, it is a weak acid. So H2S give HS negative along with H plus. Now initial concentration. So initial concentration of H2S is 0.1 molar and it is 0, 0. Now, at equilibrium, if alpha is the degree of dissociation, then it is 0.1, 1 minus alpha, it is 0.1 alpha, 0.1 alpha, right? So that means, what is the value of Ka? That is 9.1 into 10 raised to power minus 8. So Ka equal to Hs negative ion concentration, H plus ion concentration divided by H2S concentration. You can write here, if alpha is degree of dissociation of H2S. Okay. Now, as value, say Ka is 9.1 into 10 raised to power minus 8. So again, 0.1 minus 0.1 alpha, that is very close to, because we can neglect alpha, so it becomes 0.1 only. Okay, so Hs is 0.1 alpha, again 0.1 alpha divided by 0.1 only. Okay, and that is equal to 9.1 into 10 raised to power minus 8. So 0.1, 0.1 cancel. So value becomes 0.1 alpha square equal to 9.1 into 10 raised to power minus 8. That is alpha square is equal to, yes, 9.1 into 10 raised to power minus 8 divided by 0.1. Okay, so in this way it becomes, yes, 91 into 10 raised to power minus 8. So alpha is equal to square root of 91 into 10 raised to power minus 4 only. That implies alpha is equal to, yes, what is the square root of 91? 9 and 81. देखो 9 9s are 81 and 10 10s are 100 and value is 91. Means it is midway, almost midway. Okay, so value is almost 9.5 into 10 raised to power minus 4. That is alpha. Okay, alpha is 9.5 into 10 raised to power minus 4, right? And concentration of Hs negative. So Hs negative ion concentration is 0.1 into alpha. So that is 0.1 into 9.5 into 10 raised to power minus 4. So it becomes 9.5 into 10 raised to power minus 5. Right? Beta 9.54, okay, into 10 raised to power minus 4, because there is square root of minus 8 also. Alpha becomes, see, alpha is equal to 91 into 10 raised to power minus 8 raised to power 1 by 2. Ralam? Got it? So this is the first part. We have calculated HS negative ion concentration as 9.5 into 10 raised power minus 5. Okay. Now case 2. Case 2. Case 2 was calculation of HS negative ion in 0.1 molar HCl solution. Okay. Again start H2S to give H plus and HS negative. HCl is giving H plus and Cl negative ion. There is common ion effect. So due to common ion effect, equilibrium shifts backward. Equilibrium shifts backward. And that's why the dissociation of H2S is further suppressed. Now let us take again the equilibrium. See, HCl is a strong acid. So whatever HCl concentration is, that is 0.1, it becomes 0.1 and 0.1 only. So that means in H2S, because of the presence of HCl, now H2S is 0.1 molar, right? So H plus ion are also 0.1 only. Okay. So now we have to calculate HS negative ion concentration in the presence of HCl. Okay. Earlier say we take it as 0. H plus ions are taken as 0 in the first case. But now H plus ions are 0.1 molar due to the presence of HCl. Okay. Yes. So now this is initial concentration. Now at equilibrium. Now at equilibrium, it is 0.1 plus X. Sorry. H2S 0.1 minus X. So it becomes 0.1 plus X. And it becomes X. Common ion effect can occur in reactant side, but if ions are present, beta. Okay. But in most of the cases, it is on the product side only. Okay. So at equilibrium, let us say X moles of H2S are dissociated. So X moles of H plus and X mole of HS negative ion are formed. Okay. And X can be neglected. So it is very close to 0.1. It is very close to 0.1. Okay. Now Ka, this is actually Ka1 on both the cases. See, because only first H plus ion. So Ka1, we can write it as Ka1. First dissociation constant of H2S. Okay. So Ka1 now it is equal to again H plus ion concentration, HS negative ion concentration divided by H2S concentration. Okay. So Ka1 is 9.1 into 10 raised to power minus 8. That is equal to 0.1 into x divided by 0.1. So 0.1, 0.1 cancel. Okay. So x becomes 9.1 into 10 raised power minus 8 only. And that is the concentration of HS negative. So now HS negative ion concentration is 9.1 into 10 raised power minus 8 molar when HCl is present. When HCl is not present, then it is 9.5 into 10 raised power minus 5. Okay. This first and second case is just like that of the question number 44. Now come to the next calculation of S2 negative ion. Okay. If second dissociation constant is given to us. Case 3. Second dissociation constant is given. Ka2 is given to us. Value is 1.2 into 10 raised power minus 13. Keep in mind, higher ionization constants are always less than the lower. Okay, like Ka1 is 9.1 into 10 raised power minus 8, and Ka2 it is 1.2 into 10 raised power minus 13. Because when H2S is neutral, so H plus removal is easier, but HS negative, it is difficult to remove positive ion from a negative ion. Okay, so dissociation constant goes on decreasing. Okay, so case 3 is calculation of S2 negative ions in the absence of HCl. Okay, so H2S first it is converted into H plus and HS negative, and Ka1 is equal to 9.1 into 10 raised to power minus 8. Okay, now HS negative. It gives H plus and S2 negative. So Ka2 is 1.2 into 10 raised power minus 30. Okay. So overall Ka, what is overall Ka? If we add both, that is H2S to give 2H plus and S2 negative. Okay. Rupesh Aduwala, just send your mobile number. I will send you the buffer solution lecture. Okay. So Ka equal to Ka1 into Ka2. We are adding these two equations. So it becomes H2S to give 2H plus plus S2 negative. If equations are added, equilibrium constants are multiplied. Okay. So Ka will become Ka1 into Ka2. What is Ka1? 9.1 into 10 raised power minus 8. And Ka2 1.2 into 10 raised to power minus 30. So just multiply it. 1.2 into 9.1. It becomes 1.092 into 10 raised to power minus 20. Okay. Right. So this is K. So it means this is the representation of dissociation of H2S to S2 negative. See, initially H2S is 0.1 molar. It is 0, initial concentration. Now at equilibrium, it becomes 0.1 minus, instead of X, now it is Y. Beta, HS negative, they are cancelled. Okay, HS negative is cancelled by HS negative. Okay, so 0.1 minus Y. So if one H2S is 1 mole of H2S is ionized, we get 2 moles of H plus. Okay, so if Y moles are ionized, we get 2 Y moles of H plus and Y mole of S2 negative. Okay, now Ka is equal to H plus ion concentration raised to power 2 S2 negative raised to power 1 divided by H2S. Okay, now Ka value is 1.0292 into 10 raised to power minus 10. That is the value of Ka. So 1.092 into 10 raised to power minus 20, that is equal to 2y whole square into y divided by 0.1 minus y, that is equal to 0.1 only, because y is very less. Keep in mind, whenever dissociation constant is less than 5%, then we can neglect y or x or alpha, whatever it is, okay, as compared to the concentration given to us. So it is around about 0.1 only. Okay, so it becomes 2 to the 4 y square into y square, means 4y cube over 0.1 equal to 1.092 into 10 raised to power minus 20. That implies 4y cube is equal to 1.092 into 10 raised to power minus 21. Okay, so y cube equal to 1.092 over 4. Beta, how we know y is very small? Because dissociation constant is very less. If dissociation constant is less, means H2S is less dissociated. Say it is 10 raised to power minus 20. From here we can get the idea. Got it, Ralam? Into 10 raised to power minus 21. Right? So y is equal to 1092 over 4. So it becomes 10 raised to power minus 24 into 1092 over 4. So 4 to the around about 273 raised to power 1 by 3 cube root of it. So y becomes 10 raised to power minus 8 and 6.49. Okay, that means almost 6.5. Okay, 6.5 into 10 raised power minus 8 molar. So that is the concentration of S2 negative ion, that is equal to 6.5 into 10 raised power minus 8 molar. It is in the absence of 0.1 molar HCl. Okay. Now case 4. Now calculation of S2 negative ion. In the presence of 0.1 molar HCl. Okay. Wait, beta, wait. This is the question of 5 marks. Okay. So calculation of S2 negative ion in the presence of 0.1 molar zero point 0.1 with calculation of S2 negative ion in the presence of 0.1 molar HCl. Okay. So now again we have H2S to give 2H plus plus S2 negative. It was the case. Okay. So now it is 0.1 molar. Okay. H2S is 0.1 and H plus concentration, it is also 0.1 because we are doing the calculation of H2S, sorry, S2 negative ion in the presence of 0.1 molar HCl, right? So, and it is 0. Initially, this is the case, initial concentration. Okay. Now at equilibrium, it is 0.1 minus, take it as Z. So it becomes 0.1 plus 2Z and it becomes Z. Okay. Now Ka again, it is H plus ion concentration raised to power 2, S2 negative ion concentration divided by H2S concentration. So Ka is same, 1.092 into 10 raised to power minus 20. Now say 0.1 minus Z is round about 0.1. Again it is 0.1. Now it becomes very simple question. 0.1 raised to power 2 into Z divided by 0.1 only. So 0.1 is cancelled. So it become 1.092 into 10 raised power minus 20 equal to 0.1 into Z. That implies Z is equal to 1.092 into 10 raised power minus 20 into 0.1, sorry, Z, okay, 1.092 into 10 raised power minus 20 divided by 0.1. So it becomes 1.092 into 10 raised power minus 19. So S2 negative ion concentration now it is 1.092 into 10 raised power minus 19 molar. See, now let us see the difference. In first case, HS negative ion concentration, that was 9.5 or 9.54 into 10 raised power minus 5 in the absence of 0.1 molar HCl. When we have HCl, then HS negative ion concentration becomes 9.1 into 10 raised power minus 8 in the presence of 0.1 molar HCl. Now come to S2 negative ion concentration. So S2 negative ion concentration is equal to 6.5 into 10 raised to power minus 8 molar in the absence of 0.1 molar HCl, and same S2 negative ion concentration is equal to 1.092 into 10 raised power minus 19 molar in the presence of 0.1 molar HCl. That's it. Okay, this is due to common ion effect, because due to common ion effect what happened, H2S become H plus and HS negative. So due to common ion, when HCl is there, then what happened, due to common ion effect, dissociation of H2S is suppressed. Okay, due to common ion effect, dissociation of H plus is, so H2S is suppressed. Now in case of H2S to give 2H plus and S2 negative ion, again when HCl is present, then due to the presence of again common ion effect, dissociation of H2S is further suppressed and S2 negative ion concentration decreases. Here HS negative ion concentration decreases. Okay, so that's all for the day. We have done only 2 questions, but they are very, very important as well as conceptual. Okay, they are all, both are concept based questions. I hope you understood these questions. If you have any doubt, please do ask. Yes, beta. Any doubt? Or I'm signing off now. Yes, beta. If you have any doubt, please do ask. Okay, good night, Ralam. Okay, beta. Bye-bye then. Take care. And please go through this video again. Okay, who is this elite education? Okay, so Ralam is present today, Anika is present, Abhay is present. Then what about Mansi, Sakshi, uh, all others? Okay, great.